Hey everyone. Sweet. Before we start properly, I kind of need to address the elephant in the room. If you have seen Jurassic Park, can you throw your hands up in the air? Okay, could have gone terribly. If you had your hand up and you actually didn't like the film, can you leave it up? And then leave? If you haven't seen the film, I mean, it's been 30 years, like, I can't, there's spoilers, so I'm sorry. Through chaos theory, the film highlights how even the most sophisticated systems can be brought down by the most unexpected events, like Dennis Nedry. And to bring this back to software development, and not just dinosaurs, our systems often fail not because of the more obvious features and components, but the more subtle, insidious bugs. Which brings me to the concept of chaos engineering. Chaos theory, software development, chaos engineering. This was championed by Netflix. This was championed by Netflix with their Chaos Monkey. Chaos engineering throws you into pure hell and demands you employ the necessary measures to pull yourself back out. With Netflix, they built a program to randomly turn off instances of your running code in production, to stress test the system in a way that was less contrived, and they could work out how to cope with those realistic outages, and they released it as Chaos Monkey. Chaos engineering forces you to look failure in the eye and try not to blink. Now, we go back to dinosaurs. If you remember the scene where Dr. Ian Malcolm places a droplet of water on Dr. Ellie Sattler's hand, he explains the concept of chaos theory while watching the water run in a random direction based off tiny, imperceptible changes in the environment, her hands, the wind, whatever. A droplet of water dropped onto a human hand is akin to sending an HTTP request to your API, with no two requests have ever executed under the same conditions, which is honestly terrifying, and I don't know why we do this to ourselves. But the most important takeaway from that scene is unpredictability in complex systems. Jurassic Park was not built to handle Dennis Nedry flapping his beautifully deceptive wings. It couldn't have predicted him, but maybe it should. But maybe it could have put in measures to cope with the various consequences he brought around. No software is actually simple, despite what your managers may try and convince you of. The problems and bugs arise from software seem to be kind of ridiculously disproportionate and quite frankly annoying for what you would perceive as the simple software. So given we're going to face unpredictability, we know one thing: we can be certain things will fail. So maybe instead of chasing perfection by stomping out every single conceivable bug, we just let go. Accepting failure as a certainty means switching gears into handling that inevitable failure more proactively. Build a system that isn't brittle, but bends and flexes with the oncoming storm. So with our new pessimistic giddiness, let's begin. Testing, which, I know, it's very boring, but apparently quite helpful. Let's go back to basics. There are only two reasons why we test our code, as far as I could find for this talk. We reduce bugs, and we build system confidence. And that tends to manifest itself in the following ways and goals. Firstly, we want to protect our data. An application state is temporary. It can be blown away, it can be restarted, but it's temporary. But the data is a permanent source of truth. Protect it at all costs. We not only want to prevent bad data from entering our data stores, but we want to store that data reliably. Secondly, we want to foster an acceptable user experience. And I do say acceptable, we're not miracle workers. Data consistency is key, but it's useless in a silo. It needs a usable counterpart to experience it. Step one, just like Lexi, we need to get to know our system like she knows Unix. One of the best ways to get to know something or someone is to build trust. And that trust is largely and positively affected by consistent behavior. The more consistent we can get our system to behave, the more we trust it, it's great. We can build that overall system trust. Step one in that trust building exercise is to identify all of the important critical functionality in our platform, in our application. Extract that functionality into small, isolated, reusable units, which can be easily testable. Unit testing. Unit testing is great. But honestly, writing endless unit tests is not my favorite thing to do. I find them bloated, hard to maintain, noisy. So I tend to skew time-effort ratio more towards high-yield value tests, which would be integration tests. John Hammond, forever helicopter bossing. Firstly, we want to shortlist the most critical user flows in our system. We want to ensure that these flows are available as possible. And available means it works, and it works consistently. Once we have that list, we want to be able to run those flows over and over again in a repeatable fashion in an isolated environment. This environment would likely be production-like, not production, but production-like. It's production-adjacent, one would say. Ideally, not staging. This tends to be used for developers, product owners, managers to test features manually. You want something you can just spin up, blow away, and be as close to production as possible. Deploy your whole system into a temporary environment, only accessible internally, very important. Run the tests and flows, delete the data, destroy the environment. No one will ever need you there. And a lot of companies and teams deploy feature branches in this fashion. These user flows can be really simple. Like in those, I can't do that, 9 lines. 9 lines, we can potentially touch multiple services. Signing a user up, make sure they're there. Like we have touched so many internal services. Various validators, data stores, like error handling. Integration tests are going to be slower than unit tests, but in my opinion, testing your whole components, or all your components as a whole sum is just invaluable. But let's continue building trust in our system. Alongside consistent behavior, trust is built on honesty. And the easier it is for me to look at some code and to figure out what it's supposed to do, the easier it is for me to assess what might go wrong. The more I have to kind of hold in my head and I can't work it out, I struggle to then pick it apart. But moving on from testing code, we look at writing code. The less of the system I have to hold in my head, the better. Code that's easier to understand, is easier to debug, is easier to extend. Be obnoxiously explicit about what functionality will do. Lots of implicit magic is great if everything's working, but as soon as you need to peek behind that curtain, you have no idea what you're going to see, and it's scary. Any unwritten knowledge that is not widely known in a company is referred to as tribal knowledge. This can be fantastic for job security, because they can't get rid of you, but terrible for the team maintaining the application. I've now been on both sides of that, and I didn't realize how frustrating it was to try and deal with the person who had the tribal knowledge and not have that documented. When I had it, it was great, because they can't get rid of you. In theory, no one knows a piece of code better than its author, which is, again, fantastic on a solo project, but once again, terrible for the team maintaining it. If we look at this slide, which this took me a while to build, so we'll stick here for a bit. If I've written some code, then I'll have built those kind of pathways in my brain to know exactly why I did it, when I did it, how I did it, my motivation. And in my own brain, I know how it works. And every time I work with that piece of code, those same pathways light up. And I'm like, oh yeah, it's that. However, you worked on a different piece of code. You created different pathways. So when you come to work on an intersecting feature, which uses both pieces of code, you're essentially reading a map where only 50% of the lines are visible. The rest are blurred. And you're a smart developer, so you can use your experience and your intuition to kind of get yourself to the destination. But due to the blurring, you're completely blind to the potholes and the bumps along the way, which sucks. And the name of the game is basically extract. This took a long while as well, so we'll stay here for a bit too. The name of the game is extracting that tribal knowledge from our brains. Like, you have all of this disparate knowledge spread, and some overlaps, some not. And we kind of want to get it out. Like, there's no magic answer here, and no company I've ever worked for, present company included, has ever got this right. And I hope they do one day. I hope everyone does. But there's no silver bullet to this. It's just a constant combination and effort and contribution of documentation, testing, communication, knowledge sharing, demos, screen recording, pairing. Like, it just goes on and on and on. But it has to be consistent, kept up to date. And unfortunately, the answer is not always more. There is a there's a pile of perfectly articulated documentation lying, I'm sure, in everyone's Dropbox server, like iCloud, whatever you put these things, GitHub, that no one's ever read. And it's okay just writing it. But whatever the methods, it needs to be centralized, easy to maintain, and kept up to date. As complexity in a system grows, it's inevitable that the more sophisticated solutions are employed. Unfortunately, what happens is with that sophistication comes an increase in cognitive load. The harder it is for me to reason about. One piece of code calling another piece of code is fairly straightforward to reason about. I just follow that thread, and however far it goes down, I just keep following it. As we start to employ more sophisticated methods to meet the ever-growing needs, naturally, we do increase the mental effort in understanding our system. We get offshoots, we get asynchronous, we get things dealing with things in other bits of the system. So one way we can start to unblur those aforementioned map lines is to be transparent about how our service, that I've held in my head, interacts with your service and how it can interact with every service. And one simple example, I wouldn't recommend keeping it on a slide, but somewhere else would be that kind of directory. If you're going to use the system I've built, then here's the things you need to know. Here's the gotchas. Unknown unknowns. One of the worst things about unpredictability is that you often don't know what you don't know. So how on earth can you begin to handle failure if you don't know what dangers lie ahead? Donald Rumsfeld was attributed with the following quote: "There are known knowns, there are things we know we know. We also know there are known unknowns. That is to say, we know there are things we do not know. But there are also unknown unknowns, the ones we don't know we don't know." I felt like reading The Cat in the Hat. There was a lot of stuff going on. What this thought framework enables is for us to utilize what smarter people than me call the taxonomy of uncertainty. Ooh. The taxonomy of uncertainty, or the Rumsfeld decision matrix, is an organizational pattern that places us in the very center as the observer and allows us to describe the fidelity of knowledge to which we understand various external systems. The observed. We are observer, they are the observed. These pairings, observer, observed, with all their various configurations, can simply be labeled using the known-unknown taxonomy, giving us a very rudimentary theory of knowledge. Fancy words aside, why the heck is this useful? This is useful because it lets us deeply assess our own and our team's working knowledge and understanding of complex systems. We're not going to be able to plan features and functionality effectively if we don't at least have a basic understanding of the current system and a basic understanding of our own basic understanding. I know, sorry. It also gives us into an insight of where our weaknesses might be in times of emergency. You don't want to figure out that no one knows how to use the email part of the system when everything's flooding in and it's gone down and no one knows how it works. And you're being bombarded with, why aren't the emails sending? As we know, the answer to that question will be, I don't know. In the above matrix, the top left quadrant is the safe zone. We've got features and code that we have a high degree of understanding and a large safety net of gracefully handled errors if things go wrong. We want as much of our system to sit in that top left. The villainous quadrants are the other three, and the bottom right one is the worst of all. Let's delve into more ways we can kind of shove everything more towards that top left. I'd like to think I'm not sat in a room full of Dennis Nedrys. If I am, then I have some issues. But let's continue. Lack of awareness or understanding is a precarious place to be. This often occurs when the following has happened, or one of the following has happened. You're new to a team, you're new to a company, you're new to a code base. You've inherited legacy or external code. You just simply lack necessary skill. I've lost count of many times I've sat in a planning meeting and someone said, okay, Ben, you have everything you need to complete this task. And I've gone, yep. And there's not a single thought going through my head about how I'm going to do it. Bug fixing is one of the best ways I've come across to gain realistic system knowledge. None of the bugs or situations you're going to be presented with are contrived. They're all literally things going wrong with the actual system. You're facing real user systems, real user issues. And the only way to fix them is to get your hands dirty and start poking around the code base into various files, running things. Without knowing where to start, your only tool is your own intuition. Documentation and blind guessing as you tumble down the rabbit hole. But you do gain invaluable knowledge and insight along the way. Second way is great, is just grab a ticket and build something. Keep the PMs happy. Try and pick a feature which exposes you to multiple, and if possible, unfamiliar areas of the system. Pick something which has low urgency, maybe low importance. Just hovers above, it doesn't really matter if this gets done, but it will give you lots of insight. One of the first things I tend to do when I join a project or a team is to change a value in a data store here, and then have it display here in like an app or an API or whatever. And that way I've known that it's at least gone through an entire kind of end-to-end flow, the data flow, and I can understand how that's happening roughly. Documentation for a project should be kept up to date and easy to follow. I struggle with following this, but you should all definitely do it. And if you're setting up a project for the first time, follow the steps in the README and then add to it, modify it. This is out of date, and this is the gotchas I found, and this is what I had to install to deal with that dependency. And if you're working on an existing project and you're bored, Occasionally just reclone the repo and just start again. Sometimes you mess your local Git branch up and you kind of just, well, that's what you have to do. And that gives you the opportunity to keep new hire developer experience smooth sailing, onboarding experience great. Faulty assessment. This often arises when we've inherited functionality, or someone's left the team and they've created a knowledge gap. There's no glamorous way. This is just straight up homework. Consult any docs you can. Try to speak to the original author of the code during any handover period. If they've left the company, find out where, call them. Do what you need to do. Sometimes the only course of action is to simplify it, rewrite it, simplify it, cut down the damage it can make. It's better to have a slightly less glamorous solution that you can handle than one fancy bit of code that just goes boom one day and you've got no idea why. Sometimes you've just got to throw your hands in the air and admit defeat. This area of the system is not your expertise. You maybe don't know the language or something. You don't know the infrastructure involved, and it's just too complex for you to even rewrite it. You don't know what to do with it. Isolate it. Literally just isolate it. Isolate the complex piece of functionality so it doesn't bring the system down. Like, that's maybe all you can do. Controlling that blast radius of that inevitable boom gives you that small amount of breathing room while you do the homework, phone the ex-colleague, hire an expert, ask ChatGPT, all these things. I would like to take this opportunity to talk to you about oven gloves. I once worked with a wonderful colleague who honestly hated writing consumer-facing code. He much preferred writing developer-facing code, internal libraries that enabled other developers to write user-facing code, and he had the concept of oven gloves. And giving us developers and me at the time, which I needed, was a thick pair of oven gloves. I can't really do a lot with thick pair of oven gloves, but the one thing I can't do is burn myself very easily. So I get less flexibility, I can't change as much, I don't get maybe lower level access to this library or something, but it was reducing the damage. So you give up the flexibility and how they implemented it, but I'm less likely to break stuff or burn my hands. So now we've covered all the ways we're kind of lacking as developers, we can start to focus on the positives. And it starts from building a system from the ground up. I'm sure everyone's done this at least once. You spent an enormous amount of time building an A1 system, and 6 months later, the database is full of your automated test users. And I once spent a year building a side project, and it had one paying customer. And every single deploy, I thought, I really hope he likes it. As much as you can avoid prematurely optimizing your system, every single system starts with 0 users. When you have that guaranteed viral hit, you can start cranking the scaling levers once you're flooded with signups. Write it, make it work, then make it work faster at some point. Working code can be shipped code, can be revenue-making code, can be customer-facing code. So we've agreed not to prematurely optimize, but we need to figure out kind of which direction we're aiming. And sadly for John, the perfect system does not exist. And that's because each application has its own subjective needs, not one objective benchmark. Each application needs, or deserves, a baseline of acceptable functionality. It should be performant, available, secure, and store data safely. Beyond that, depending on what type of application you're building, will depend on where you can aggressively skew your efforts. A medical app could have the fastest loading times in existence, but could be catastrophic if it malformed data when it saved it. The better we know our system from the earlier trust building exercise that we did, the better decisions we can make in terms of what to optimize, when, and all these kind of take under the umbrella of quantified risk. More trust, more knowledge we create, we can decide how quantified these risks are. So we decided to centralize our data access methods into a neat library and expose the find method, which is wonderful. Now, an example of future-proofing this find method would be just to put a default limit. Just across the board, every single select or find you're going to do from database, just put a default, sensible high limit. So don't build in pagination from day one. If it takes you 20 minutes because you're really good, then do it. But you don't have to. So that default limit just covers us from wildly inefficient queries, and it's likely that the thing we're building probably won't have more than 1,000 things in it from day one. So when it does, great, good problem to have. Extend it to support pagination. As previously mentioned, Netflix decided to throw caution to the wind and deliberately cause mayhem in their production environment because maybe they were bored. and they release Chaos Monkey to the world. This tool randomly kills instances within your application while your customers are using it. It's a bold move, but it seems to work, leaving you no choice but to building those mechanisms for handling failures. We can take Netflix's lead, and we can inject some malevolence into our system. There's no magic, there's no complexity needed. We can simulate a DDoS attack by just hammering our code with a silly high loop count and record the results, see where the weaknesses were, see where it slowed down, see where it crashed. You've then got you want to be able to simulate, again, production-like experiences. So one thing you could go through the different scaling gears is different loop counts, different speed, and then refactor with those realistic findings. So it's great that we now know, how to break our system, but ideally we'd kind of add a bit of hardening in the first place. Bad data can be really, really painful to track down and remove. So strict data validators will save you a huge amount of time and effort further down the line. As I said earlier, an application state should be pretty much ephemeral. And if you trust your developers, which you should, it should be fairly safe and reasonable, if it's been built the correct way, to give developers access to just turn the system off and on, like just restart it. And have you turned it off and on, just oddly and annoyingly tends to be the fix for most issues. Testing in production. Sometimes you just have to. There are a very, very, very short list of acceptable features, in my opinion, that you can only truly test in production. Making real money payments is one of them. If there are others, I would happily add them to that list, but I don't think it's much longer. But if you are going to test a feature in production, have as many questions answered as you can. What if the payment fails? Does the user know? Are balances incorrectly updated? Can the payment be retried? I don't know the answers. This is your app. You have to find these answers out. As system complexity grows, it's less likely that your development environment is going to be able to kind of replicate the sophistication of maybe infrastructure or scaling that production does, and there's not going to be that one-to-one mapping with production. So aside from putting your laptop in production, we just have to try and find ways to replicate that, to kind of try and turn those gears. And there are lots of methods that you can employ to make sure your code will run correctly and predictably across multiple instances, multiple regions. Idempotent operations, unique constraint, locks, leader elections, X, Y, Z. These are just ways that we're trying to replicate, fancy, schmancy AWS environments or whatever. Weakness and brittle. Brittle code breaks, flexible code flexes. If we want to build that resiliency we're shooting for, we have to expect our application to be used in ways which we would never expect, which often happens when you're showing someone for the first time. I'd show stuff to colleagues and they'd use it wrong, and I think, what the hell are you doing? Never expected that. It's very, very easy to get caught in the trap of things are going to be okay, and that's wrong. It's really easy to think, I've built it this way, I've built it to work, and things shall always be. It shall always work in this way. I write this, and I think, save to DB will always work. Marvelous. And to my complete surprise, someone changes something further upstream, change a validator, and this now throws an error, blowing up the whole sign-up flow. And I never saw it coming. It's basically about acknowledging, it's being less optimistic. Acknowledging for every single happy eventuality, there also exists a sad eventuality, and then handling it gracefully. If you can develop with that duality in mind, and seeing those two dual scenarios running at all times, then you just save yourself so many hours like down the line. And if you're feeling too happy and your application is running far too well, start throwing random errors in your code and see how the whole application responds. Expose those brittle points yourself. Like, I'd rather expose it on my laptop than it get released and 3 months later a potential customer finds it, because that would suck. Getting to know application means we can make more informed decisions about error handling. Again, like increased knowledge, increased trust, quantified risk. We can then decide how we want to make this error handling work, for example. If I have a request that goes through service A, then service B, but A fails, what happens? Does the whole request abort? Do we continue to let B have a go? I don't know. Again, this is your app. As a concrete example, when a user signs up to our system, we want them to send them an email and save them to the database. If the email sending part fails, we don't really want to bail the whole process, lose the user sign-up info, and have to politely ask them over intercom or something, can you do that again? Because I didn't handle it correctly. The most straightforward solution is to isolate the email sending part. And so if or when, and when it does blow up, that blast radius is contained. And our sign-up flow can continue. So they didn't get the email, but we save them. And then we can retry that email. In my mind, the primary function of a user sign-up is to store the user's details. And if they get an email in the next 10 seconds, then wonderful. But if it's retried 1 minute later, that's a bonus. If they get it at all, also a bonus. So let's just broadcast an event in the background. And any other system, part of the system that cares, can handle that from some queue, send the email, wonderful. We can, one, store the user details quickly in the database, more quickly. And the initial request from the user will be responded to quicker. So they're not waiting for your email sending part to create a HTML template. Which leads me nicely onto production is on fire, and we need to debug. And your system's in a bad state, and it was probably from that error you threw it before. This is sort of like a sort of choose your own adventure for geeks, but not as fun. Have you tried turning it off? Yes. Was there a bug deployed? Was a config changed? No. Is it crucial? No. Then you have various different scenarios for various different. This will look fairly differently for your system. Some steps may be missing, but essentially you want to try and answer those questions or have them answered in some sort of run book, some sort of what to do in times of crisis. The problem is a lot of the time we don't really want to look where the problems are because that is scary. So some people can bury their head at times. But if I've learned something, it's that sitting in that discomfort and looking where we don't want to look actually makes it easier to deal with that scenario if and when things go wrong. The same wonderful other colleague also gave me this advice when I first deployed the system, and it just didn't work. And his answer was annoying and impenetrable, and honestly completely correct, because no situation I've ever been has been improved by panic. So in a complex, unpredictable system, risk is inherent. So we may as well work with it, not against it. Each system will have different needs. Spend acceptable time optimizing for the higher priority needs. Skew towards what your application actually does versus that baseline. Assess which sad paths can be revisited at a later date. Which need addressing right now, which can be addressed in a future-proof way. Try to avoid the premature optimization, put it on a later to-do. Protect the data store at all costs. You don't want that bad data finding its way in. Bad state can be fairly easily recovered off on. But bad data is hard to track down, it's hard to recover, and more insidiously, you may not notice. So errors could be swallowed, bad data could get in. You have no idea until 6 months later someone says, where on earth is this thing? And you find out it never stored correctly, or it lost it. Things will go wrong, and when they do, have a plan in place. Design with resiliency in mind, pay close attention to how services communicate, and how each dependent service behaves if downstream services respond, crash, take longer. Work out those intertwining links. Which operations can run in isolation? Which need to run in an order? Can they run in parallel? Do they need to run serially? How do they respond to each other's successes and failures? Do they all need to respond together? Do you need to wait for X, Y, Z before this can return? I would say this is like step one. Decide in your application which is the most mission critical ones and concentrate all your efforts there. Where does the data go? Where do the words go? And then eventually hold on to your butts, essentially, which are very wise words. No one wants to be sat trying to debug 2 million lines of code when production is on fire or dinosaurs are escaping. No one saw Dennis Nedry coming, but maybe allowing an entire system to live in one developer's brain with no documentation in sight could have been avoided. And as a lovely bonus round, I thought I would ask ChatGPT on the very real problem of avoiding Jurassic Park's downfall. So I asked it what measures could be put in place to prevent Dennis Nedry causing the damage he did. But before I do reveal the answers, the answers ChatGPT suggested, would any of you, smart room of developers, like to shout out any ways which you yourself would have prevented Jurassic Park? Just lives at risk. Nope. Okay, fair enough. Background checks and security clearance. Prior to hiring employees, a comprehensive background check and security clearance should have been conducted. This would have revealed any criminal records or history of suspicious activities that could pose a threat to the park's security. Employee monitoring. Regular monitoring of employees' activities and other critical could have detected Nedry, his unusual behavior, very odd fella, leading up to his act of sabotage. This would have given the security team an opportunity to even intervene before he kicked off that series of events. Access control. Seems to be he was control of everything. Access to the park's computer systems and other critical infrastructure should have been restricted and controlled. Different levels of access could have been assigned based on job responsibilities, and access logs could have been closely monitored or reviewed for any unauthorized access. Redundancy, not of Dennis Nedry, but the park system could have been designed with redundancy in mind to ensure that a single point of failure did not cause catastrophic damage. This would have mitigated the impact of Nedry's actions. Regular security audits. Regular security audits could have been conducted to identify any vulnerabilities and ensure that the park systems were up to date and effective. So if only John Hammond had ChatGPT in 1993, we'd be great. And that is the end. I'll bring it to an end. Is there any questions at all?
I think one of the biggest things with documentation, in my experience, is documentation is often immediately out of date.
Yep.
Any tips on how to keep documentation up to date? I think the out of date stuff can often be worse than nothing at all.
Yeah, sorry, so the question was like, what are the practical tips for keeping documentation up to date? And like you said, right, I'd rather have maybe no documentation than wrong documentation. That can send me down a rabbit hole in the wrong direction, where I'd maybe rather establish my own rabbit hole. Again, like there's not really any answer, there's just lots of little tips. Most of it's developer, discipline. It's like team discipline, keeping each other accountable, approving PRs, or maybe not approving them if supporting documentation hasn't been updated. Like have that as part of the whole review process. Auto-generated documentation, I've been down that rabbit hole before. It's kind of cool when you just run a command and it creates load documentation, but then it lacks that human element of gotchas and kind of motivation and stuff. I don't know, maybe there's going to be AI-generated documentation that would be able to capture more of a developer prose approach in its wording. But yeah, essentially you either go from dry documentation auto-generated to out-of-date documentation. So I would say developer discipline, keeping it part of a tight process which everyone buys into, and it's essentially mutually beneficial. Yeah?
Yeah, one of the companies I worked for, they actually had a dev that was assigned on a monthly basis to documentation maintenance, and it would rotate, so because no one loves that job,
Yep.
but everyone realized the advantage of it, and
Yep.
so they would actually like kind of be responsible for just kind of skimming the documentation on a regular basis, just to kind of make sure that things weren't out of date.
Yeah. So the tip is to actually dedicate some time to it. I kind of always do it as an afterthought, if I remember, if someone prompts me, but actually dedicating some proactive time to doing the tasks which are on the axes of important and urgent. Documentation is rarely urgent, it's always important, and it only becomes urgent in the times of crisis. So carving out 10% of a week, 10% of your day, 10% of a 4-week cycle, like whatever it is, to dedicate to documentation, put it on a rota. If you break production, you're on documentation duty, you know? These things, I don't know. Any others, or? Yeah.
I have a question. When you're talking about simulating an environment that isn't quite staging in development, but is a standard for production, I was wondering if you could just go more into that, especially like, you talk about a lot how protecting the data store is important. What type of things are you doing to recreate the scale of your production data store so you can test that in an environment where you can just blow it out?
Yeah, it was the same other mid developer who set that up at my last company. He, again, loved that sort of stuff. So the question was, how do you go about practically setting up that production-like or production-adjacent environment in a repeatable, automated fashion? Kubernetes was the answer for him. He took, essentially, production, scaled it down slightly, created an environment. He actually sucked down all of production data, anonymized it, put it into a database, and then you're kind of running it. Again, you're never going to get one-to-one parity with production. But if you can do these little things to kind of maybe recreate data, or, I mean, if you're scaling down infrastructure, you're going to hit earlier scaling problems than in your beefy production service. So it kind of exposes that brittleness as well. But yeah, Kubernetes was his answer, and sucking down production data and anonymizing it, seeding it with that data was the way to go for him. Cool. Good. Who's my favorite dinosaur? That's a question I really hoped that would get asked, but never expected. I really liked, well, we can agree Dennis Nedry was a bad guy. So when he met his comeuppance, that whole, if anyone's got the technical name other than Umbrella Dinosaur? Yeah? Oh, you have the name, oh, come on. So we're going to go for Umbrella Dinosaur. Yeah, so you can picture it doing that.
Sorry, I thought the question was who. I mean,
Who?
Who is your favorite dinosaur?
Who is my favorite dinosaur?
Barney.
Well, I mean, you've gone out of the Jurassic Park cinematic universe into the Barney cinematic universe. So I kept it scoped to Jurassic Park. So what is my favorite dinosaur? Not who is my favorite dinosaur. Okay. I like the elegant brontosauruses at the start when he first goes, welcome to Jurassic Park, and they're doing all that sort of stuff. So, yeah. Yours? Pterodactyl. Okay, nice. Any advances? For this turns into like a David Attenborough documentary. But otherwise, yeah, we'll leave it there. Thank you very much for listening.